Hi, Honors Algebra. Today we are starting Chapter 8. So you should have your 8.1 notes in front of you today. And we're going to start by using the completing the square method for solving a quadratic equation. So if you could grab your notes and let's go ahead and start going ahead and doing these warm-ups. You could press pause if you want. If you're done doing your warm-ups, then we could solve this by actually factoring. If you recall, we can factor x plus 6 times the quantity x minus 6 equals 0. And if you set each factor equal to 0, you're going to have x equals negative 6 and x equals positive 6. So there's one method by factoring. Now, the other method we can use is the square root property method, which says if we have expression squared, we could actually get that and isolate that term by getting the other, our constant to the other side of the equation by adding 36 to both sides, and then we could easily take the square root of that. And remember that the square root of 36 is both positive and negative 6. So we still have two answers. So either way works. What I want you to do right now is go ahead and factor that. And once you factor, press pause right now and then press play again when you're done. So here we have a factored form right now. This is actually, it's simplified form, but if we go ahead and factor this into two binomial factors, we're going to get x times x. And remember, we're looking for two factors such that when multiplied give us positive 9, yet when added give us negative 6. And that is both negative 3 and negative 3 here, which ends up giving us the quantity x minus 3 squared as our final answer in factored form, okay? So these are warm-ups from what we're going to actually do today. And today we're going to show you how to actually solve using the square root method along with completing the square. So just like we showed you in the warm-up 1, I can actually use the square root property method because this is my leading coefficient, which 1, which is in the form x squared equals some constant. So when you have a square root property method set up like this, you could actually find and take the square root of some value, and it's going to be plus and minus the square root of p, or some number. So we have this set up perfectly for us. So since x is already by itself, x squared, we can actually square root that on both sides. So if we take the square root of 56, the square root of 56, if you factor tree that, or look for factors such that one of them is a perfect square, I have the square root of 4 times the square root of 14. And if we try and factor tree 14, I just get 2 times 7. Nothing is paired up. So unfortunately, it just gets multiplied and stuck under the radical. So I have plus and minus 2, because the square root of 4 is 2 root 14. And that is my final answer. Now, I could write my answer like this, or I could actually separate them as positive 2 root 14, or one answer as negative 2 root 14. So either way works. So I just want you to see that this includes both, and this separates them both. Okay, here, since I have my quadratic term, and I have a constant, I don't have a b term. In other words, I don't have a quadratic form of an equation in standard form because I don't have a linear term. So when you're missing that linear term and you only have your quadratic and a constant, just like we did here, just like we do here, we can actually use the square root property method. So I'm going to isolate this square term by subtracting 16 from both sides. And then I'm going to go ahead and divide by 2. And I'm going to get negative 8 equals, negative 8 divided by 2 equals negative 4. Now if I square root this, recall in chapter 7, at the beginning of the chapter, we said, we can't do this with a real number system. We can't take the square root of a negative number. But in our complex system, we can. We're actually going to have an imaginary part. So remember, the square root of negative 4 is the same as the square root of 4 times negative 1, which is 2, and the square root of negative 1 is I. So we're going to have x equals plus and minus 2I. Okay, so again, we could write them like this, or you can separate it as 2I and negative 2I. All right, in your answer book, you may find that they do separate them. So if you're wondering, hey, I didn't get that answer, that's probably because they separated them and you didn't. We'll accept both. Okay, so now the fun part. When you're solving a quadratic by completing the square means we want this to be, sorry, I forgot about C, everyone. Forgive me, I forgot about C. So let's go back and do this. If you heard that noise, that's because the video editor just made a big noise. Let's go back and do C. So here I have my quadratic term and I have a constant, okay? So what I want to make sure that I do is I want to go ahead and isolate this term. So I'm going to add 12 to both sides. So I have the quantity z plus 3 squared equals 12. And just like in chapter 8, I want to go ahead and square root both sides. So I'm going to have z plus 3 equals the square root of 12. Now the square root of 12 is the square root of 4 times root 3, which is 2 root 3. But I have to have plus and minus 2 root 3. Okay? And then, since the square and the square root cancel out, that's why I'm left with z plus 3. Now, to solve, I want to get z alone, isolate that by subtracting 3 from both sides. You have to be careful, though, because I have negative 3 plus and minus 2 root 3 as our final answer. Now, remember that the negative 3, and the 2 do not get combined because this is one term and 2 root 3 is another term. It's like saying you can add negative 3 plus 2a. You can't. You don't get negative 3 plus 2a and get negative 1a. It's negative 3 plus 2a. In this case, it's negative 3 plus 2 root 3. And then you also have negative 3 minus 2 root 3. So separated, you can say z equals negative 3 plus 2 root 3 as one answer, and you could say z equals negative 3 minus 2 root 3 as your other answer. So you can write them as a combined answer, or you can separate them all together. Okay? And this is the end of our first video. Sorry about that, but we're going to watch video 2 now, and we're going to complete the square on the rest of the 8.1 notes, day 1. Thanks.